I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you want.
Okay, so our topic today is ICE, which stands for internal combustion engine. Are we together? Yes. Which stands for internal combustion engines. So we're going to start talking about just a few things that I want us to talk about before we move on. We're going to explain first in ways in which we can calculate the power in an internal combustion engine, right? Then after that, we're going to, after we're done with the ways in which you can calculate or measure power in an internal combustion engine, then we're going to talk about the internal workings of a combustion engine. Are we together? Now, if you notice, your engine has got the cylinders and everything else, and then the output power of the engine is put on the crankshaft. Are we together? And then from the crankshaft to the flywheel. Are we together? Now all these tests are coming from the flywheel. They're connected by the flywheel of the engine. So they are used to test the overall power of the engine. So the first one, we've got the rope brake test. Now, with the rope brake test, in order for you to understand it, right, it's quite simple for you to understand. Don't worry. So with the rope brake test, the flywheel, which is this one, right, is then connected to a pulley, and then from the pulley you've got a spring on the other end, and then on the other end you've got a weighted load. So it's how much we're able to carry this by the engine, or how much the engine is supposed to, how much the force, my English is running away, how much force or how much power is the engine exerting on your load will then be the power that is then produced by the engine. Now that makes sense, right? Sweet. So we've got a few things that we need to talk about. Now because of something like this, we're going to start first by measuring torque. Now what is the definition of torque? Torque. You can call
the rotational force.
Rotational force. You can call it rotational force. You'll be correct. Now, torque is normally calculated in engineering science N1 and N2. Torque is calculated by radius multiplied by force. Are we together? Now, in this thing, it's still absolutely the same thing. There is no difference. Are we together? So, in order for us to get our torque, the formula is going to say the mass of this weight, the mass of the weight minus the mass of the spring that we have here. Because the spring is also counteracting the mass of the item. So we're going to subtract this from this so that we can find out how much weight is the engine only pulling, not the assisted by the spring. Are we together? So it's going to be the mass of the weight minus the weight, the mass of the spring, multiplied by, in order for us to get force, multiplied by
9,8.
9,8. That is correct. 9,8. And then after 9,8, and then we multiply it with the diameter. Are we together? So it's going to be multiplied by the diameter divided by 2 to get the radius. Are we together? That is our formula. That is our formula for calculating torque. Now, if you want to calculate power, what's power? Can you give me the definition of power?
Power is the rate at which work is done.
That is correct. Power is the rate at which work is done. But you can take power and you can calculate it from torque. Are we together? Now, the formula in which we use to calculate power from torque is 2 pi nt. Now, we've got different types of powers that I want us to look at. Are we together? Yes. Now, all of these powers are very, very, very important. Are we together? Right? The first power is called brake power. Now, brake power is not necessarily on the wheels or the brakes of the car. Brake power is measured at the flywheel. Are we together? So when you are using this formula to calculate power, because our test measures at the flywheel, right, then that means what you're measuring is literally brake power. Now, brake power doesn't care how many cylinders you have. It only cares about what is coming out at the flywheel. Are we together? So this is the formula in which you can use to calculate your brake power, 2 pi nt. But then if you are not given the torque, then you can substitute this formula to calculate your brake power. Are we together? Yes. Nice. So it's actually 9.81. Okay, so there's an example that we given here. Let's just do this example quickly, right? They say an 8-cylinder double-acting 2-stroke diesel engine with a brake torque of 296,200 Newton meters and rotates at 1,800 revolutions per minute. Determine the brake power of the engine. So they just gave you a whole lot of information that is useless. Are we together? So let's start. They say that this 8-cylinder, not important in this case. Because for brake power, if we are doing the rope brake test, brake power is measured at the flywheel. Are we together? So there's no need for us to include the cylinders, right? The next one, they say it's a double acting. Doesn't really matter if it's single acting or double acting because we're calculating it at the flywheel. Are we together? Yes. 2-stroke engine. Doesn't matter if it's 2-stroke or 4-stroke. Doesn't really matter. With the brake torque. Now this is where it matters now. So they gave us a torque of 296,200 Newton meters. And then they say that it rotates at 1,800 revolutions per. That is correct. Your N is at 1,800 revolutions per minute. These are formula, right? Now let's talk about something else that I did not include here. Now, in terms of power, is it calculated per minute or per second?
Power is per minute. The rate at which work is done.
Yes.
Per seconds.
Per second. That is correct. Power is calculated per second. Now look at this formula that I gave you. You say power is equals to 2 pi nt, right? Your brake power is equals to 2 pi nt. But then our n represents your rotational frequency. But then your rotational frequency in this case is given in revolutions per minute. So that means in order for us to get our brake power is called BP, brake power, right? Which means we will say 2 pi nt, which is equals to 2 times pi times n, which is 296,000. Oh, sorry, that's t, sorry. Then this one is 180. And all of it is divided by 60 to convert it to
rotation per second.
That is correct. What do you get your answers? So what do you get your answers?
This is kilo. This is mega.
Let's see. Tell me your answer, then you convert it.
It's 5,583,583,288.
There's no comma.
469. 464.
464.
Yeah.
Okay. This will just be your answer in watts. Are we together? So we normally use our answer in kilowatts. So that means we're going to say now answer is 5,583,238 kilowatts. Or if you want to take it to megawatts, you can as well. But mostly we just leave our answers like this. Mostly we just leave them like this. But if you want to take it to megawatts, it's also okay. But the problem with taking your answer to megawatts is that these questions, this is not the end of it in normal questions. You will have other questions that feed up on top of each other. That means you'll have to convert it back to kilo again. Now here's the thing, right? Here we're doing the rope brake test, right? Yes. So here's one thing that I need you to remember. The rope brake test, our torque, we calculate it from the radius of the flywheel. Are we together, right? That's why we calculate our torque, from the radius of the flywheel. That's why the diameter is divided by 2. Are we together? Now when it comes to the prony brake test, right? This is the last one. For the prony brake test, it's still also exactly identical, but where we measure from becomes different, right? So if you want to measure like a lot of torque, right? If you've got a smaller radius, that means you will have to compensate a smaller radius with tons of force, right? But if you've got a bigger radius, then you don't need tons of force. That means a prony brake test can measure, large amounts of torque more than the rope brake test. Are we together? So let me try to draw this to the best of my abilities. God did not give me that blessing of drawing, so Forgive me on that one. Okay, so this is your, obviously, this is your flywheel, this is your brake shoe, then this is your mass, then this is your spring. So what we've done in this case now is we've replaced the radius of the flywheel, right? And now we're now looking at the length of the arm. That's the most important now. Now we're focusing on the length of the arm. Because if you can get this thing to move over a long distance, that means you don't need that much force. How would you get it? Switch. So for your pronate brake test, the formulas are still one and the same. So your torque formula, or let's start with your brake formula. Then we go to the torque formula, right? Now, or we can do this example that is here because they didn't give us a formula. But I know this stuff is simple. I know I have it in my head. So your brake formula, brake power is still the same formula. 2 pi n t. How would you get it? This is your brake formula. It will never change. Well, you'll have another additional formula. But then this one would never change. How would you get it, right? And then for your torque, the formula that you're given for torque is going to be the mass multiplied by the gravity multiplied by the force. How would you get it? This is the formula that you're given. But you're going to notice that the mass multiplied by the gravity, sorry. I said force, that's wrong. Sorry. This is the force multiplied by the length of the arm. Yes. Now, what you're going to notice is that this is going to be different when it comes to the calculations that you're going to do. They're going to give us additional stuff if they're in the mood for it. So let's just look at this question that we're given, right? They said, during a brake power test with a pronate brake, the following details resulted, right? Then they gave us, they said mass at the end of the arm, which means the mass here, right? So this mass was given at 47,6 kilograms. This was given at 47,6 kilograms. The mass of the weight that was given on the other side. And they say the length of the arm was given at 914,4 millimeters, right? And then the last thing that they gave us was, they say the engine speed, right, which is the revolutions. They said the engine speed was equal to 120 revolutions per minute. This is the formula that they give it. Now the question says determine the brake power, right? Yes. That's the formula, determine the brake power. Now let me be clearly honest with you. In order for you to understand this, you need to do as many examples as possible. Because some examples here include the thickness of the rope as well. Are we together? So I need you to do as many examples as you can. But you will do them as soon as we start doing past exam papers. Now, the question says, determine the brake power. Are we together?
Yes.
So in order for us to get the brake power, we need to get the torque first.
Yes.
But if you're lazy, you can, not lazy, efficient. If you're efficient, you can incorporate the formula for torque into the formula for brake power. Now the formula for BP says 2 pi nt, right?
Yes.
2 pi nt. But we do know that T is equals to mgl, right? Which is the mass multiplied by the gravity multiplied by the L. If you are given the mass of the spring, you also subtract it. Are we together? Because we don't want anything that is going to negate the force that should be exerted by this mass. Are we together? So it depends question by question. But we know that torque is equals to mass by gravity multiplied by length. So here in brackets for torque, we're going to say multiply by the mass, by the gravity, by the length, then in close bracket. And then everything divided by 60 because of this thing. So it's going to be 2 multiplied by pi, multiplied by n, which is our rotational frequency, 120, multiplied by the mass, which is given at 47 comma 6 multiplied by gravity, which is 9.81 multiplied by. Let me ask you the last question. In terms of length, what SI units do we use? Do we use millimeters or do we use meters?
Meters.
That is correct. So here we've got 914,4 millimeters. That means when you convert it, it becomes 0, comma?
Is it millimeters?
Yeah.
Okay, that's 914, comma 4.
Oh, there you go. Yeah.
4.
There you go.
Then you
Yeah.
divide it by 60. And then the final answer is equals to, I was like, that's too small. That can't be the final answer.
Over 60.
5,365. 5,000?
365, comma
365, comma.
646.
This would be in watts, right? And then if you want to convert it to kilowatts, here is the trick. Most of your answers you'll have to use them in kilowatts. I don't know why they decided that, but it's the best way to handle these numbers. Kilowatts. What do you think? Simple or difficult?
Simple.
Simple. Now let me wrap the other side and let's discuss indicated power now, right? Now here's my explanation for this. Right? Do you know that cars are about 23% efficient
The efficiency for a car is 23%.
or less?
That means it's not that reliable. Yeah?
No, it is reliable. It's more reliable than electric cars. They need a software update to start working. I prefer gasoline cars to electric cars. But you know that their efficiency is about 23%. Now, let's talk about it. Now, we're discussing brake power. When we say brake power, we calculate it at the flywheel, right? That means at the end of the engine. Once the engine is done, that's the engine's output, right? So let me write it down. BP. You can look at it as the engine's output, right? This is the output of the engine. But we do know that the power is not produced at the output of the engine, right? The power is produced inside the cylinders. Are we together?
Yes.
Now, inside the cylinders, the power that you produce is known as indicated power. Now, indicated power, I'll tell you, is more of a theoretical power because you can't use it anyways. It's difficult to use. You can only use it after losses. That's where you get your brake power. So indicated power, you can look at it as the theoretical power. This is the power that you calculate per cylinder, per cylinder, per cylinder. Are we together? Now, we're going to look at 4-stroke engines, then we're going to look at 2-stroke engines. We're going to look at how a 4-stroke engine works, and we're going to look at how a 2-stroke engine works. Are we together? Now, it's all about the cycles, in other words, how many revolutions does it take to produce power, right?
Yes.
Now, for a 4-cylinder engine, power is produced once every 4 cycles, right? And if I say 4 cycles, in every 2 revolutions, right?
Yes.
Okay, now let's start again. Now for a 4-stroke engine, right?
Yes.
You've got your cylinder like this and you've got your piston like this. Now, when your piston is obviously connected to the crankshaft, right? Now, when your crankshaft moves half a revolution, right?
Yeah.
That means that if your piston was here, it is then moved to here. Are we together? That means for half a revolution, your piston moves downwards. The other half a revolution, your piston moves upwards. Are we together?
Yes.
So that means in 1 revolution, your piston moves up and down. Are we together, right? Now, if you now have 2 revolutions, your piston moves up and down 4 times. Are we together? Sweet. Now, let's see how exactly does a 4-stroke cylinder works, or how does a 4-stroke engine works. Now, the first stroke is obviously inlet, right? Where we take the air, we put it in, right? And then the air-fuel mixture goes in at the inlet, right? That's the downstroke. And then the upstroke, when it goes up, is called compression, right? All the valves close. Inlet, only the inlet valve opens. And then down there, when English. Okay, when the piston moves downwards, right? That's the inlet. And then the inlet valve opens, right? And then when the piston moves upwards, that's one full revolution. That's compression, that is correct. And then all the valves are closed. Are we together?
Yes.
And then when your gases, your air-fuel mixture is compressed, the spark plug is going to do its thing, spark and ignite the fuel. And then when the fuel is ignited, that is going to push the piston downwards. Are we together? That's power. Are we together? So power has been produced, right, at the third movement of the piston. Now, the fourth movement of the piston, the upward stroke, right, the last stroke, the inlet valve is closed, but then the exhaust valve is opened. That means that we took 2 revolutions, 4 piston movements to produce power watts. Are we together?
Yes.
Okay, so that means now when we are now looking at the value for N, for a 4-stroke engine, right? Let me do 4 like this. For a 4-stroke engine, the value for N would be N, which is in rotational frequency, right?
Yes.
N for a rotational frequency are divided by 2. Are we together?
Yes.
Why do we divide by 2? Because you need 2 revolutions to produce power watts. Are we together?
Yes.
That's for a 4-stroke. Now for a 2-stroke engine, that's a motorbike, right? Now for a 2-stroke engine, it only needs 1 revolution, right? That means that, why did that happen now? I'm getting old. Let me restart the diagram again. I don't know why I rubbed it off. Okay, you still have got your crankshaft, and then here's your cylinder, and then here's your piston inside the cylinder. Now, this one is made differently now, right? With the 4-stroke cylinder, the inlet and the exhaust are up on top, right? But then this one, the inlet and the exhaust are not really on top. That means every time the piston moves downwards, it's power. Are we together? That is. But not only is it power, it's also power and inlet. Are we together? Exactly. And when every time the piston moves upwards, it's compression and exhaust. Are we together? That means we push it up while we're letting the exhaust gases come out. So the exhaust is here, right? And the inlet is there. So when it moves upwards, it pushes the exhaust gases and then push downwards, right? So that means we only need 1 revolution, right? Or we need up, down to produce power, which is 1 revolution, 2 piston movements. Okay, so as you were saying, that means for going down and going up, we've already produced power ones. And you know that going down and going up is 1 revolution, right? So that means for a 2-stroke, right, is just equal to N, right? Because 1 revolution produces power. So there's no need for you to change anything. But now we've got what we call a double acting, right? Double acting. Oh, this is extra important. I need you to know this with your heart, mind, body, and soul. Because it's extra important. Now, let's move over to the last one, right? Now we've got what we call a double acting. Now, a double acting, whenever the piston moves downwards, it has got 2 inlets and it has got 2 exhausts. So power is produced per upstroke and per downstroke. Are we together, right? Power is produced always. So if power is produced always, N for a 2-stroke, but double acting, N is equals to N times 2. The rotational frequency multiplied by 2. Are we together?
Yes.
Okay, now let's start to the formula now. Now, the good news is that all your formulas are simple. Right? It's more like an acronym that you can use, that you use to remember your items with. This is the workout in the heart. I've lost 3 kgs rubbing this board. Okay, so let's move on, right? Now, we were saying that formulas, right?
Yes.
Now, let me give you another formula for brake power again, and then I'll give you another formula for indicated power. So for brake power, this is your second formula. Guess what is it? Blame. Are we together? And for indicated power, Guess what's the formula? Or it's not supposed to be kept?
Plain.
I'm telling
What
you.
is plain? Plain.
Why is it plain and why is it plain? Okay, no, it's very, very easy to understand. Trust me, it's very, very simple to understand. Okay, so let's start with the E. Let's start to the end, then we work our way back to the front. Because I want to leave the B and the P's for last. Now, the E is the number of cylinders. Are we together? Right? Number of cylinders. So, if you've got 5 cylinders, the value for E is 5. Are we together? If you've got 6 cylinders, the value for E is 6. So it doesn't really matter how many cylinders you have. E will always represent the number of cylinders that you have. And guess, what does N stand for?
Rotational.
That is correct. But now that rotational frequency now has to obey these laws. Are we together? Sweet. Now next, can you guess what the A stands for?
Area.
Area, that is correct. A stands for area. But now this is the cylindrical area, right? Inside the cylinder, that's the area of the cylinder. Are we together? Sweet. And what does L stand for?
Length.
That is correct. L stands for your stroke length, right?
Stroke
So that is how much is the piston moving, right? So if your piston is able to go like this, then that would be your stroke length. So L stands for your stroke length. Remember that all your units are supposed to be in meters. Are we together?
Yes.
Here your N is supposed to be revolutions per seconds. That is correct. If you want to use revolutions per minute, then you divide by 60. Sweet. And then we've got B and P. Now, for brake power, the B stands for the mean brake pressure. Are we together? Mean, which stands for average, right? Mean stands for average, which stands for mean brake pressure, right? And can you guess what the P stands for? If the B stands for brake pressure, what does the P stand for? It stands for indicated pressure, right?
Yeah.
This is the mean indicated pressure. This is the pressure of the cylinder. So that's the mean indicated pressure. That's your formula. Oh, but now that you've done this already now,
Yes. So,
you can answer some questions in the final exam.
how many marks does it come with?
Depending on what you're given. Sometimes they may give you the rope brake, sometimes they may give you the pulling brake test. And then they want you to calculate indicated power in your brake power, then you have got lots of marks. But then if you're starting from just using this formula, you don't have a lot of marks. So let's talk about MA. MA, you know this one with your heart, body, and soul, don't you? What does MA stand for? Yes, what you're thinking is correct. MA. Engineering, science, and what?
Mechanical advantage.
That is correct. MA stands for mechanical advantage. And what is the formula for calculating mechanical advantage?
Load
Over effort. That is correct. Load over effort. So for your mechanical advantage, your load over effort, your formula now for calculating mechanical advantage is going to be brake power divided by indicated power. Are we together? Your mechanical advantage is like your efficiency of your engine, because it's testing out the brake power divided by the indicated power. How do you calculate efficiency? It's output divided by input, right? Now, this is what you get at the cylinders, right? Then this is what you get at the flywheel. So this is your output, and this is the engine. This is the power that your engine is supposed to produce. So that's your mechanical advantage. They can put it as a percentage, so it's also okay. I will check. That is correct. So there's a question that we have here, right? Which says, the following results were attained on a single cylinder, 4-stroke diesel engine at a speed of 200 revolutions per minute. The mean effective pressure was 602 kilopascals, and the cylinder diameter is 305 millimeters. The stroke length is 457 millimeters, and the brake load on the pronic brake is 84.4 kilograms on a length of 1,372 meters. Now let me write down the given information. Then we'll see what we can do, right?
Rotational frequencies.
No, wait, let me start. The following results were attained on a single cylinder. What value are we given? We say on a single cylinder, So what value are we given? E is equal to 1. Are we together? On a single cylinder, 4-stroke, right? So just because you said 4-stroke, we're going to keep it to the back of our minds. Then it's going to come back later on to help us, right? 4-stroke diesel engine with a speed of 200 revolutions per minute. Now, N is equals to 200 revolutions per minute. But don't forget that they say it's 4-stroke. Are we together? So if they say it's 4-stroke, that means N is divided by 2. Are we together? So now we're going to say 200 divided by 2. Well, you need it in seconds anyways, right? Multiply by 60. So what do you get your answer as? I am thinking your answer is 1 comma something.
One comma 667.
I would have gotten it correct. 1,667. This is now revolutions per second. Are we together?
Yes.
They say the mean effective pressure. Now the mean effective pressure that they're giving us is this one. Are we together? If they wanted to give us that one, they would have said brake pressure. Are we together? So the mean effective pressure is 602 kilopascals. Right? So P is equal to 602 kPa. Now they're saying that the cylinder diameter is 3 or 5 millimeters, right? What do you use diameter to calculate? Area, right? What is the formula for calculating area?
Pi d squared over 4.
That is correct. So it's going to be pi multiplied by the diameter of 305 millimeters. Can you convert 305 millimeters for me?
305. That's 0,305.
Now, if you itemize this in the calculator, what do you get?
You get 0,239.
0,239. 239. Can you give me another number after 0,2? 954. This is equals to meters squared. Are we together?
Yes.
Now, let's read some more. They say the stroke length is 457 millimeters, right? So L is equals to, can you convert 457 millimeters into meters?
That's 0,45.
That is correct. And they say that, and the brake load on the Crony brake is equals to 84.4 kgs. Now they're giving us the mass, which is 84.4 kilograms. And they're also saying that it has got a length. Now let me use this as bold. It has got a length of 1,372 meters. Now let's see what the questions are asking for. Now. The first question is saying, calculate the indicated power in kilowatts. Are we together? Yes. Calculate the indicated power in kilowatts. Now let's look at this question, right? Calculate the indicated power, IP. Now here's the trick. Here's another method of doing it. But don't do it now because it'll be pretty useless, right? Don't do it now. But if you are not given all this, if you're not given the number of cylinders, if you're not given the pressure or the area or the length, right? You can use this method. You can calculate your brake power. Then from brake power, then you can make a plan to get the indicated power. I'll show you later on in this question. So let's calculate indicated power first. IP is equals to plane, right? So that is equal to P is given at 602. Remember, we don't convert kilopascals to pascals. We just use them in kilopascals. Are we together? 602 multiplied by the length, which is equals to 0,467 multiplied by the area. Now, if you still have this in your calculator saved up in your memory, just click answer so that your answer can be as close to the correct one as possible. 0,23954 multiplied by the rotational frequency is 1,667 multiplied by the number of cylinders, which is 1. What do you get your answer? That answer is wrong, this answer is wrong. You forgot to square it. No.
Oh. Ish.
The answer is 0,0.
7306.
Okay, keep that answer in the calculator, then we're going to use it. 0,07306. Yeah. What is your final answer now?
33, comma
That is correct. 33,
507
kilowatts. Now let me ask you a question. Why is our answer in kilowatts? Because we used our pressure in
kilopascal.
That is correct. That is correct. Okay, the next question is asking us to calculate the brake power. Are we together? Right? The next question is asking us to calculate the brake power. Now, here is something that I need you to keep in mind always, right? You see, I want you to keep in mind that the value for N that we used here, right, is not going to be the same value of N that you're going to use when you calculate for brake power, BP, right? Now, remember our formula for brake power, if you're given all these things, right, we can't use this one because we don't have brake pressure, are we together? So we're going to use our formula, which is 2 pi nt, right? Now, remember that you can also factorize your formula for calculating torque, right? Which is equals to m by 9.81 multiplied by the length. Are we together? This is the length of the arm. Now in the final exam, or when you're revising this, I want you to be able to differentiate between the length of the arm and the stroke length. You see, these two things are not the same. The stroke length and the length of the arm. So that when you're now putting this into your calculations, you do good, man. So it's equals to 2 multiplied by pi multiplied by n. Now the n is not 1,667. Why is it not 1,667? Because 1,667 was used specifically to calculate indicated power. Because we're using this one specifically to see which pressure, which cylinder is working and which cylinder is working per which revolution. Are we together? Here we don't care about the cylinders, we only care about the flywheel. Are we together? That's why we're going to say 200 divided by 60, not multiply anything by 2. 200 by 60 is 3,33333. You know, I'm awesome. Okay. Multiply by, this one is given to us as 84,4 kilograms. Multiply by 9,81. Multiply by the arm length, which is 1,372. What do you get your answer?
23,767.
23,000.
767, 837.
Okay, your answer will be in watts, right? But let's make sure that we use the same answer. So let's convert this to kilowatts. It will be 23,760,
67, 837.
So this is now 68. This is in kilowatts. Are we together? Yes. This answer is correct. And now for the last question, which wants mechanical? The question says calculate mechanical efficiency. Right? Mechanical efficiency is the same thing as mechanical advantage. But they say the efficiency, that means we multiply by 100. Are we together? So our MA is equals to BP divided by IP multiplied by 100. Of which our BP, we got it as 23,768 divided by 33,507 multiplied by 100. Then what do you get?
70.
No, you forgot to multiply by 100.
That would be 70.
70, comma
70,934.
34%. Done dead. Steadily. Now, our lesson stops here.